Morning viewers, this is Kasturi Day. Today I'm back with the this one motion chapter, motion in one dimension chapter according to ICSE syllabus class 9. Okay. So I was discussing this with you in my last two videos. So I will start with the today's discussion. Before that, I will request you to please to subscribe my channel so that and also press the notification bell so that you can be updated with the, as soon as the you can get the notification as soon as a new video is uploaded. Okay? And if you are liking the video, press the like button, share with your friends so that they can also be benefited from these videos. And one more thing, I'm telling you from the last few videos, in my last few videos, I'm telling you that please to meditate before starting your day. That will help you in a lot, if you not in any respect, in any of the work which you do the whole day, in your life also it will help you a lot. Not only you, your parents also can do it. Your any of your elder brothers, sisters, they can also do practice this meditation. Okay, and this will help them everybody. For getting concentration, increasing your concentration in whatever work you do, and also you will get more interest in what you are doing. Okay. So let's start with the meditation first for 1 minute, and then we will start with the discussion. Okay. So for meditation, please concentrate on a point of light. You can switch on a bulb and also concentrate on that. Please think that this bulb or this point of light is sending you rays which is reaching you and giving you a lot of energy. Your whole body is getting the energy. Each and every part of the body is energized with this light. You're getting power. Your mind is becoming peaceful. You can put in what you inside into your new things can come inside your mind. You can store everything that you want. So the storage capacity for mind increases. Your working power increases. You feel more enthusiastic, more energetic, more happy with the time. Everything is stressful. This life is such a magic. Just giving you all energy, such a balance. So what in my last video was discussing about this graphical representation of linear motion. Three types of graphical representation. One is displacement time graph, velocity time graph, and acceleration time. So first we come to displacement time graph. So displacement time graph from rest, for rest, when a body is at rest. So that rested body, the displacement time graph would be a straight line with zero slope. Like the first graph you see from the picture, see it's a straight line parallel to the time axis. Time is x-axis and displacement is the y-axis. So, yes, displacement is y-axis, time is x-axis, and this slope will be 0, and the time graph, displacement time graph will be a straight line which is parallel to the time axis. Okay, so this will be the representation of a body which is at rest. The next B graph is a graph of uniform motion. If a body is in uniform motion, that will be also a straight line, but with non-zero slope. Okay, and the line will pass, the straight line will pass through the uh, intersection of the displacement and the time axis. That is x and y axis where it is meeting from the 0 point. It will pass through. So it's a non-zero slope. It is also a straight line of uniform motion. Okay. Now, displacement time graph of uniform acceleration is a parabola. See, this third one is a parabola shaped. The graph is a parabola shaped. So, this is a parabola shaped, indicating that it is a graph of displacement time, and it is indicating the body is at uniform acceleration. Okay. The displacement time graph of for rest, uniform acceleration, and uniform motion is given below. That is the thing what is. Then we come to the slope of the displacement, some important points regarding displacement time graph. Okay. The slope of the displacement time graph with time axis measures the velocity. Slope of a displacement time graph. That is, the displacement time graph is giving a slope, anything which is giving a slope. So this is a slope, but it is non-zero. This is a zero slope. Here it is non-zero, and this is a parabola slope. Okay. So this slope indicates what? It measures velocity. Okay. Now positive slopes indicates positive velocity. Displacement and velocity being measured from any reference point in the outward direction, it shows that the body is moving to the reference point. Okay. So displacement and velocity, which is being measured from any reference point in the outward direction, the slope which is coming out from the intersection point. Okay, that it is coming out from outward direction, any reference point, if it is being measured, if the displacement and velocity is measured, it will show that the body, it shows that the body is moving away from the reference point. That means, what is it? That if, for example, see, if we consider this graph and the body, this is the uh, graph which is coming out, that is outward direction. And any point, if we consider this point or this point, so if there is any point on this slope, if we consider, and we want to find the displacement on and the velocity of that moving body, it will be moving out from the origin, from this intersection point. It is moving out. Okay. So that is what it is telling. Then next is negative slope of a position time graph or displacement time graph actually indicates negative velocity, which means the velocity of the moving body, moving object is moving in an opposite direction. It does not mean that the velocity is decreasing. It does not mean that the velocity is decreasing, but it is moving with the velocity in opposite direction. That is, if this slope is this one, then the moving body will be moving like this. It will move this way, coming down. So that will, it does not mean that the velocity is decreasing, but it is moving. If it is coming down this side, if the graph is coming this side, then it means the velocity is there, but it is moving in opposite direction. Next is graph of negative velocity need not move below the x-axis. It may not move below the x-axis. It can move in the x-axis, in the positive side of the x-axis also. Okay, but it also does not mean that the velocity is decreasing, but it will be showing that the velocity is, the body is moving in opposite direction. Now this is the above image. You can see this graph. You can see there's a position, that is the displacement, and this is the time. Okay, position here it is displacement. There is x-axis, y-axis is displacement or position, and x-axis is time. The above image is a negative slope because and our negative velocity in the position time graph. See, the velocity is coming down from, it's rising from here, it's starting from here, and it's coming down, so it has a negative velocity. The graph does gradually moving downward, indicating the slow rate of negative velocity. The velocity which is becoming negative. So next is this one. See the image, this image now, this is also a position time graph. Here it is also a negative slope of position time graph. See, it's starting from here up on the y-axis. It's starting from here and it's coming down. So displacement time graph, but as the negative slope is comparatively more than the previous graph. With the previous graph, it was not so much, right? See, with the previous graph, it is not so much slanting. Okay, but in the this graph, it is much more. The slope is much more slanting. Okay, much more steeper. So it is concluded that the rate of negative velocity is fast. The concept of negative velocity of a position time graph is in terms of acceleration is the same. Okay. If this, in terms of acceleration, if we consider, this is, we are considering velocity, but if we consider in terms of acceleration, that is also the same. Okay. Next is how to determine the slope of displacement time graph. So how to determine it? See, B is B point. If we consider a point B on the slope, on this straight line. Okay, so if we consider B, we will see it's 4 and 40. That means from here we drop a line on time axis and also drop a line on straight line on rather perpendicular on the displacement side. That is y-axis. So we get 4 and 40 at the index point. And this one A point is 2 and 20. So therefore, the slope is y2 minus y1 by x2 minus x1. That means y2 means 40, y mark, that is 40, and y1 is 20. Okay, and x2 is 4 and x1 is 2. A and B we have considered. So that means what? 40 minus 20, that's 20, and 4 minus 2 is 2, that's equal to 10. So slope will be equal to 10. That means the velocity is 10 meters per second. As we know that the slope of the displacement time graphs is the velocity. Therefore, the slope, which is 10, that means the velocity is 10 meters per second. Okay, clear? Next, we move on to velocity time graph. Okay. Now see. Now, the slope of the line on the velocity time graph reveals useful information about the acceleration of the object. Now, velocity time graph, the slope of the velocity time graph gives information of acceleration of the object. Like in displacement time graph, the slope indicated the velocity. Here in velocity time graph, the slope indicates the acceleration of the object. Now, if the acceleration is 0, then the slope is also 0. It is a horizontal line. Okay, horizontal line. It may be parallel to the x-axis. Okay. If the acceleration is positive, then the slope is also positive, an upward sloping line. Okay. Upward sloping line. This is a positive line. You can see this is an upward sloping line. The second picture. The first picture, that is parallel to the y-x-axis, and that is here acceleration is 0. Therefore, the slope is also 0. If it is positive, then the slope is upward sloping line. Now, the velocity time graph of uniform velocity is a straight line. This graph can be used to calculate the acceleration of the object. Okay. Velocity time graph of uniform velocity, then it is a straight line, and this graph can be used to calculate the acceleration of the object. The velocity time graph of uniform velocity is a curved line like the displacement time graph. But if it is non-uniform velocity, if it is a uniform velocity, then we can calculate the acceleration. But if it is non-uniform velocity, then it is this slope. The graph will be a curved line, like the third picture. See, third image. You can see that. Sorry, this is a third image, which is showing a curved line. So crooked line is coming straight, then again it's rising, then it's becoming flat. So it's a curved line. Okay. So like the displacement time graph. Next, we move on to some other important points, that is regarding this velocity time graph only. The slope of the velocity time graph defines the acceleration. I told you from the velocity time graph slope, we can find the acceleration. So it can be said that the slope is equal to acceleration. Like that in displacement time graph, the slope was equal to velocity. Here, the velocity time graph slope is equal to the acceleration. Therefore, the following are the points which need to be understood from the slope. Okay. First is steep slope. If it is a steep slope, which represents rapid change in velocity, like if it is just moving like very steep, then it is the change in velocity is very fast. Then shallow slope, like it is moving. If it is moving like this, it's a steep slope. If it is like moving like this, okay, slanting position, then it is slow change in velocity. If the slope is negative, if the slope is negative, like it's coming from up to down, this is the negative slope. So therefore, it will be the acceleration will also be negative. If the slope is positive, like it's moving like this, then the acceleration will also be positive. Okay? The area under the velocity will represent the displacement of the object. Okay. So let's move on to the next slide. That is, this how to determine the displacement by velocity time graph. I told you the area under the velocity will give you the displacement. So this is the area under the velocity. This is the slope. This way crooked line, like curved line. This one, then it's coming back, and then it's coming like this. So it is a straight line. Then it is for negative velocity. It's coming like this. So this area, which is enclosed by the velocity time graph, this will give you what? The displacement. Okay. Now, how to find it? How to determine the displacement? A velocity time graph gives the displacement if the areas are taken under the graph with their respective signs and then added. With their respective signs, if we make out the velocity, if we make out the area and then we add it to it, then we get the displacement. Okay. So let's find out how it is done. So the net area is the value of displacement with sign. Sign represents the direction. Okay, what does this? Why do we mention the sign? Will be because if we will be able to know that whether it's negative velocity or positive velocity, in which direction it is moving. Negative means it's moving in opposite direction, and positive means it is moving in the forward direction. So we will be able to understand the direction, okay, from the sign. And the example shown, see area above the time axis will be positive. Time axis is this one, this zero line. Okay, that is the time axis. Above it is positive and down it is negative. Red color triangle, that is negative, whereas yellow and brown color figure, the area which is under these two colors, these will be positive as it is above the time axis. Then, so what do we do? First, we will find the area above the time axis. Okay? So we find D1 and then D2. Okay? So first is D1 and then D2. Okay? So area of the brown square first, and then we find the area of the yellow triangle. The first area of D1 is area of the brown square, that is 2 meters. That's a square, no? So 2 meters into 2 meters. 2 meters per second and 2 seconds. This is time axis, so 2 seconds. And here this is displacement, so 2 meter per, sorry, velocity, that is 2 meter per second. So that will be equal to what area of a square is? Side square, no? So 2 into 2, that is 4 meter per second into second. Okay, so that will be equal to 2 meters. Sorry, 4 meters. 2 into 2, that's 4. So 4 meters. Next, we move on to the yellow triangle. See how to find the area of a triangle. Half into base into height. It's a right angle triangle. So half into base into height. So half is we consider, then base is 2 seconds and height is 2 meter per second. That means that gives us what? 2 meters. So what will be the area of D1? D1 will be equal to 6 meters, right? Next, we move on to the red triangle, okay? That is D2. That is below the time axis. So it will be negative sign. It will have a negative sign. So what do? We first make the area, that is, we find out the area, that is half into base into height, as if this is also a right angle triangle. So half into 2 seconds. Here 4 to 6, that is 2 seconds. So 2 seconds, and velocity will be minus 2. See, minus 1 and minus 2. So it will be minus 2 meter per second. So that will give us minus 2 meters. So D2 is minus 2 meters and D1 is 6 meters plus 6 meters. So that will give us 4 meters. Displacement will be equal to 4. Here. So next we move on to acceleration. Determination of acceleration by velocity time graph. How to determine the acceleration? We found out how to determine displacement from velocity time graph. Now we are finding out by how to determine acceleration from velocity time graph. Okay. See, from the graph we can see there is a slope which is moving upward, positive slope. Okay. And this is not so steep, just a change in velocity is there. Okay, so acceleration is what? Change in velocity by change in time. The gradient, that is the slope of the velocity time graph, is the object's acceleration. This slope indicates the acceleration of the object. So acceleration will be equal to change in velocity by change in time. So rise and run. Okay, so what do? We take 2 points on this velocity time graph. That is one, this one, another is this one. Okay. So this portion, if we take as A, so that will be equal to, from 5 to 10, that will be equal to 5 seconds. And from this one, that is 20 to 40, that is 20 meter per second. Okay. So change in velocity is from 20 meters to 40 meters. 20 meter per second to 40 meter per second. So 40 meter per second minus 20 meter per second, change in velocity. And change in time is 10 seconds minus 5 seconds. Okay, so 5 seconds. So that will be 20 meter per second by 5 seconds. So that will give us acceleration will be equal to how much? 20 by 5. That will be equal to 4 meter per second square. Clear? And clear now how to find the acceleration from this velocity time graph. Note that if the graph slopes downward, and you will get a negative value indicating the object is decelerated. If it is moving this way, not this way, from the origin, from not it is moving from 0 to out, but it is from 40 to downwards. So that will be a negative slope. That means the object is decelerating, or it is retarding, or you can say negative acceleration. Okay. So next will be acceleration time graph. So I think I'll discuss this acceleration time graph in my next video. Please go through this. If you have any doubt, please do let me know. And if you are, if, like, let me know in the comment box. You can write in the comment box. You can write in my email ID, that is kasturi74@gmail.com. And don't forget to subscribe and ring the notification bell, and because it will give you the notification as soon as new video is uploaded. And if you are like the videos, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before you start in your day. So thank you for watching and have a good day. And do subscribe and do stay tuned with me. Okay, thank you for watching.